we are going to graph this function here. It's a little bit more complex than the last couple we've seen, but I think we can handle it. Let's start off by taking a look at the vertical asymptote. And this time I'm going to say vertical asymptotes because there's two. Because I can have two different restrictions in my denominator, that means I'm going to have two different vertical asymptotes. If I set x plus 1 times x minus 2, if I set that whole denominator equal to 0, I see that this right here gives me, this factor x plus 1 gives me a restriction of x equals negative 1. So that's going to be one of my asymptotes. And then I have another restriction for this factor, and x equals 2 will be a restriction. So let's graph both of those vertical asymptotes. X equals negative 1 is one of them, and x equals 2 is another one. So already I've created kind of another section in this graph. The y-intercept process is exactly the same. Let's set x equal to 0. So this is going to be y equals 2 over, this will be 1 plus 0, which is 1, times 1 minus 2, which is negative 2, or this is equal to 2 over negative 2, which is equal to negative 1. So I've got my y-intercept of 0, negative 1. Let's plot that on the graph. 0, negative 1. Next, let's take a look at the x-intercepts. And in one of the examples we saw before, we saw that if my numerator doesn't have an x in it, this isn't going to equal 0. And that was also because I'm not adding or subtracting anything to this, so I haven't created any shifts. So basically, I've got no x-intercepts in this example. And then it should probably lend itself to make us think what the end behavior will actually be. And there's a reason why we have no x-intercepts and we have the same end behavior of 0 for x going towards positive infinity and 0 for as x goes to negative infinity. And again, you can kind of think about putting in values for x here. This is going to get really large in the denominator. So 2 divided by a large number becomes really close to 0. So I'll have a horizontal asymptote of y equals 0. We'll put that in as well. And we are ready to graph this thing. Now, these are a little bit trickier to graph because I don't really know what this picture looks like. But what I can do here is I can try plugging in some values, or I can kind of think about what would happen if I put in these values, kind of do some mental math here. And for any values that I put in between 2 and negative 1 is going to keep this thing negative. And because I have this point here, it should make sense that I'm going to stay below the x-axis. If I were to plug in an x value that's greater than 2, then I have a 2 divided by a positive value, and that's going to be a positive number. So all of these values will be positive up here. And if I take 2 and divide it by anything where, x is less than negative 1. If I take a number less than negative 1, plug it in for x, that's going to make this factor negative. This factor will be negative, which makes this whole number positive. So that means that this section is going to also be positive above my x-axis. So this is what my graph looks like.